Welcome to section 9.1 and the start of trig class. So what we're going to do is go over the basics of section 9.1. It'll be similar to the things that you're going to see in here in the lecture. Obviously the lecture is going to cover a little bit more. Section 9.1 has a lot of vocabulary and basic ideas that we're going to use throughout the semester. So you may even want to refer back to this later, and some of it may be a little bit of review, like what we're starting with right now. So we've got to make sure everybody has the same basic terminology. Some of this is going to be a little bit of review from geometry. So let's start with a line. Okay, so we know that a line looks like that. The arrows mean that we go on forever in each direction. And then remember that a line is named by any 2 points that are on that line. So this one would be line AB, or it may be written AB with a little line over it like that. Okay, and then we can also have a segment, and that means that it has 2 ends. Okay, so there's a line segment. So there's segment AB. And then we can also have a ray, meaning it has a terminal end on one side and goes on forever the other direction. So let's say it goes like this, and the terminal side could be A or B. We've got it drawn to be A, and then right here is B, so that would be ray AB. Okay, so those are just some terms that you may come across as we're talking about this. Now what we're going to do is we're going to be looking at angles a lot, and that's going to be 2 rays that are connected like this. So they're going to go, you've got a terminal side here, and then they go on forever that way. And our kind of standard here will be vertex A, but it can be named anything. And then just to kind of have a consistency, this side is called the initial side, and it's almost always drawn to the right. So horizontal to the right is your, unless you're told otherwise, that's your initial side. And then our angle will rotate through some distance like this, and where it stops is going to be our terminal side. Okay, so initial is almost always pointing to the right, and then the terminal side is wherever that stops. And then this is our rotation, and that's sometimes called theta. That's a pretty common angle name to use. So we're going to be looking at this sort of thing a lot. All right, so let's look at 2 different, here's our terminal side here. Then we're going to have another terminal side, or I'm sorry, initial side here, initial side here. All right, now if we take this and we rotate this direction, okay, so we rotate around this way, so that would be counterclockwise, this is going to be a positive angle. Okay, so anytime we rotate counterclockwise, it's going to be a positive angle. Now, if we start from that same point and we rotate clockwise, that's going to be a negative angle. Okay, so there's a positive angle and there's a negative angle. Just looking at where it lands, looking at where the terminal side is, you can't tell because the terminal side lands in the same place, but the amount that you rotate matters. So this one's going to be positive and this one's going to be negative. Okay, so if we're going to be talking about angles, we need some way to measure this, especially if we've got positive and negative. So there's our initial side again. And one of the most common ways to measure this would be using degrees. So we start with a measure of this, and that's 1 complete rotation. Okay, so we've got 1 complete rotation, and that's going to be equal to 360 degrees. Okay. This was decided a long time ago, back by the Babylonians, not by us. We may have used something easier to work with, like maybe 100. They chose 360 and we stuck with it. So 1 complete rotation is 360. So that means that a half rotation is 180. Okay, and those two should be fairly familiar to you. You know, if you spin around one whole time, that's 360. If you go halfway around, like a U-turn, that's 180. And then, of course, 1/4 of a rotation would be 90 degrees. Okay, so at least that much should be familiar to us. Now let's talk about some common angle measures. So let's say that we have here, okay, and we're rotating anywhere up to 1/4 of a rotation. Okay, so anything up to 90 degrees, that's going to be an acute angle. Okay, so again, we're going to call this theta. So acute angle means that theta is between 0 and 90. All right, that should be familiar from your geometry days as well. And then, of course, if we get all the way up to 90 degrees, that's a right angle. Okay, so if it's between 0 and 90, it's acute. If it's in here, if we get to a right angle, then that's 90 degrees. And if we continue rotating, okay, so we continue rotating around like this, all right, if we go past 90 degrees, that's going to be an obtuse angle. So that would be if theta is between 0 and 180. I'm sorry, 90 and 180. I wrote it right. I said it wrong. So if theta is between 90 and 180, then we have an obtuse angle. And if we make it all the way over to 180, okay, if we make it all the way over to 180, that's a straight line, and that is called a straight angle. Okay, so straight angle makes a straight line. You can remember it that way. So that's if theta equals 180. Okay, and those are some of our basic angles that we may talk about as we go. All right, now two more descriptions that we may use is complementary and supplementary, and you may remember those from your geometry days as well. So let's see if we can just put these over here. Whoops. Complementary. Okay, so complementary angle. That would be if you have two angles that add up to 90 degrees. Okay, so combined, now my pictures aren't perfect on this tablet, but you get the idea. Okay, so combined, we should be able to make a right angle. So there's angle A, there's angle B, A plus B equals 90 degrees. Okay, so complementary add up to 90. And then supplementary, they're going to add up to 180. So we've got our straight angle again. Okay, and A and B are somewhere in here, like this. Maybe like that, A and B. So A plus B equals 180. Okay, so complementary combined to be 90 and supplementary combined to be 180. Okay, one relationship that you may have not seen in geometry is the idea of coterminal angles. So coterminal angles have the same initial side, okay, so we always start here, and the same terminal side. So we looked at one before that was like this. Okay, so same initial side and same terminal side. But the difference is that the angle of rotation is different. So I could, remember we said I could get here or here. My result is the same, but my rotation is completely different, and that does matter. So in this example, let's say that theta could be 300 degrees. Okay, so 300 degrees, almost 360, but not quite. And then over here, if this was the same terminal side, theta would have to be -60. So how do we know that? Because coterminal angles have to differ by 360 degrees. Another way that you could see this, so these two are coterminal. Another way that you could have coterminal angles, let's say we have this, and we've got this rotation, and let's say this is 40 degrees. I could have a coterminal angle if I went around and around like that. So what happened was I went a full 360 around, and then I went another 40 to land in the same spot. So this would be 360 plus 40 is 400 degrees. So 40 degrees and 400 degrees are also coterminal. Okay, if we don't have the picture, you can tell this because they differ by 360 degrees. So either I add 360 to one, or I subtract 360 from one, or a multiple of 360, because we could go around a few times, and you should get the other one. So for this one, let's say this is A and this is B. So if I do A minus 360, that's going to be 300 minus 360. I get negative 60, and that is the same as B. Okay, same thing here. Let's say this is C and this is D. Now this time, if I subtract 360 from this, I'm going to get a different angle. I'm not going to get the one that I want. I want to add 360 to it. So if I do C plus 360, I get 400, which is angle D, and so they are coterminal as well. Okay, so to find the coterminal angles, you're either going to be adding or subtracting multiples of 360. All right, so one place that we use this idea of coterminal angles is wanting to find an angle whose measure is between 0 and 360. So when we start getting into these functions, sometimes you need to deal with things that are between 0 and 360. So let's say that we have, for our first one, let's say we have negative 15 degrees. So this is our angle, and we want to find a coterminal angle whose measure is between 0 and 360. So we can see this is negative 15. It doesn't work. So we want to find its coterminal angle. Well, to get between 0 and 360, obviously we need to add, because this is negative. So let's add 360 to this. Okay, so we're actually going to subtract, and we're going to get 345. Okay, so is 345 between 0 and 360? Yes, it is. So there's our answer. Okay, let's try another one. Let's say that we have the angle 762. Okay, 762 is definitely not between 0 and 360. So we can see that we're going to have to subtract multiples of 360 to get this into that range. Now there's two ways that you can do this. You can write down some of the multiples of 360 and see what you need to subtract, or you can just start subtracting 360 until you get into that range. So let's say we have 762 and we say, okay, we're going to subtract 360 and we're going to get 402. All right, is 402 between 0 and 360? No. We didn't. We got closer, but we're still not there. So we're going to have to subtract 360 again. So we get 2, we get 4, we get 42 degrees. Is that between 0 and 360? Yes. Okay, so our coterminal angle is 42 degrees. All right, now if you had something really big, this could take a long time. So what you could do when you're doing these problems, if when we get into these that we need to do maybe over and over again, you could write off to the side the multiples of 360. So let's say we have 360 times 2 is 720, times 3 is 1080, times 4 is 1440, and so on. You could write like whatever, however many multiples you need. And then you could see which multiple you need to use to do this in one step. So 762, what would I want to subtract? I would want to subtract 720. So I could do this in one step if I had those multiples written out and get 42 degrees right away. Okay, so that's helpful if you have like really big angles. Like if I had, let's say I had like 1500, I would have to just keep going over and over and over again, or I could just find the right multiple to subtract. So either way is perfectly fine. It's up to you what your preference is. When you're in the homework for these and you're doing a few of them, it may be easier to figure out the multiples. Okay, so that's the basic idea there for coterminal angles.